Today we look at the second method. Okay, second method. In the last method, in the last class, we have learned the first method to solve the non-homogeneous differential equation, which is the undetermined coefficients method. Okay, undetermined coefficients method. The one that right-hand side function is a linear combination of a product functions of polynomial, exponential, sine, or cos. Okay, now today we look at the second method. Okay, and the name is variation of parameters. Okay. So this technique is used to solve, for this kind of differential equation. Okay, this is a second order different non-homogeneous differential equation, but the coefficient function it could be not the constant. Okay, you see this is ax bx dx. Okay. So if this ax bx dx are not constant, meaning that the yc will be given. Yc will be given because what you have learned is find the yc when the coefficient functions are all in constants. Okay, when this ax bx dx are all constants, meaning that you can find for the yc through the characteristic equation. Okay, but if these 1, 2, 3 ABC are not constants, meaning that yc will be given because you didn't learn how to get a yc if ABC are not constants. Okay, so if you look at the this one, I show this one. Okay, see for question number 1, this one 1, 3, 2 ABCs are 1, 3, 2. So you can find for the YC on your own. Okay, and same goes to the question B. The ABCs are 1, -4, and +4. Okay, you can get a YC on your own. But if you look at question number 2, the A, your A is x squared, B is 3x, C is -3, where A, B, C are not all constants. So YC will be given for you. Okay, because we need the Y1 and Y2. Y1 and Y2 comes from the YC. This is your Y1, this is your Y2. So that's the difference between constant coefficient or non-constant coefficient. Okay, now the right-hand side function, this one, it can be any kind, any forms of functions as listed in table 2.2. Okay, and also any form of this. Okay, there is no limit for the form of the fx. Okay, no limit. It can be any function. Okay, the only criteria is provided the function that appear can be evaluated. Okay, it can be evaluated because later on you will use this formula to get your YP. Okay, so if the function, if the integral form here can be integrated, then that means we can solve that question using variation of parameters. Okay, as long as the integrals that appear can be evaluated. Okay. So based on this, variation of parameters is actually more powerful. Okay, more powerful than the undetermined coefficients method because it can accept all kinds of the function, like trigonometric function, tangent, cotangent, secant, cosecant, or even 1 over x power of n or ln x, or e to the power of 8x squared. Also can be accepted as long as the integrals appear later can be evaluated. Okay. Now this is the formula. If not mistaken, formula is not given. This formula is not given. If not mistaken, okay, you can refer back to the past year question. Normally the appendix is the same. Okay. So this is your YP. So you see the difference, okay, between this method and the first method you have learned. The first method, to get a YP, you look at the fx, you find for the general form. Okay, then you differentiate twice, you substitute, and then you compare both sides for the coefficient functions to get the values, the constant of the YP. But for variation of parameters, to get a YP, you just need to substitute all this y1, y2, fx, ax, wx into the formula, integrate, then you will get a YP directly. Okay, everything will be from this integration. Okay, so what is this wx? Wx is the Wronskian function. Okay, Wronskian function, the one y1, y2, then you differentiate y1, y2, this one. This is your Wronskian function. And how about the ax? Okay, the ax comes from here, this one, the coefficient function of the y double prime. Okay, the coefficient function of the y double prime. This is your ax. And then your fx from here. Okay, so these are what you need: fx, ax, wx. Okay, y1 and y2 comes from yc. Okay, y1 and y2 comes from your yc. Okay, so once you have obtained this y1, y2, fx, ax, wx, okay, put them into the formula, integrate to get your yp. And then finally combine your yc to your yp, you get the final solution, the general solution. Okay, this is the flow. Okay, this is the flow. When you have a non-homogeneous differential equation, if you want to solve using method of variation of parameters, okay, we will first look at the coefficient function of this y double prime, y prime, and y. If the coefficient function a, b, c are not constant, meaning that y1 and y2 will be given. Okay, you will be given y1, y2 because we need it here. Okay, otherwise you will need to find for the y1, y2 on your own. Okay, if there are constants, if a, b, c are constants, then you form your characteristic equation, then get this yc. And from this yc, you will have your y1 and y2. Okay, then put everything in, compute the Wronskian function, then put everything into the formula. Okay, ignore the constant from the integration. Okay, this is integration, but we ignore the plus c. Okay, ignore plus c. Okay, once you get the yp combined to your yc, you will get the general solution. Okay, so this is the flow. Okay, now we look at this. Okay, we try this exercise. Okay, this is constant coefficient. Okay, so you can form, you let the right hand side to be 0, form your characteristic equation, factorize, get your m1, m2, obtain your yc. And from there, get your y1 and y2. Okay, try.
It can be used. Homogeneous and non-homogeneous can be used both of them. Homogeneous or non-homogeneous can be used with one.
This method for non-homogeneous. Non-homogeneous. For the YC. Okay, so for this, let the right hand side be 0, then get the characteristic equation, find the YC. Okay, what is your M? -1, -2. So your YC will be C1E negative X plus C2E negative 2X. Okay, so this is your Y1, this is your Y2. Compute for the Wronskian function. Okay, this is your Y1. Okay, this one is your Y1. This one is your Y2. Now compute for your Wronskian function. Differentiate. Then AD minus BC. AD minus BC. AD total up minus BC. Okay, negative E negative 3x. Okay, so -2 plus 1. This means -1. Okay, this is the formula. Okay, this is the formula. This is your fx. This is your ax. Ax is 1. So you substitute all this y1, y2, fx, ax, wx. into the formula. Y1. Okay, this is your Y2. Fx over A W plus Y2 Y1 Fx AX and Wx. Okay, then you have this. Okay, before we integrate, you need to simplify. Okay, you need to simplify. So what is the constant from this integral? What is the constant that you can factorize from here? What is the constant? Negative 4. Negative 4. Factorize. So negative, negative, you get a positive 4. E negative x. Okay, now after you factorize the 4 and negative, you have E times E times E. Okay, combined into 1. What is the new power of the combined exponential function? What is the new power after you combine this 1, 2, 3?
X. X.
2x. 2x. What do you get? 2x. Negative 2x plus x. In this one, you need to use minus negative 3x to get 2x. Okay, again, here you can factorize the negative 4. Okay, so you have minus 4e negative 2x. 1, 2, 3 combine into 1. This is the new power. 3x. Okay, 3x. Just combine these two, negative x plus x minus negative 3x. So you get 3x. Then you can proceed to integrate. These two exponential function, you can't combine these two, because this is inside the integration, this is outside. Okay, so e2x, integrate e2x. Okay, integrate minus 4e negative 2x. Okay, E3x over 3. Here you just simplify. Okay, simplify. Okay, cancel out the 2. You have 2. E. Okay, combine. You have x minus 4 over 3 E x okay, so 1 minus 1 over 3. You have 2 over 3 E x. So this is your YP. Okay, this is your YP. Then just combine the YP to your YC, you get the final solution. Okay, so I repeat, for derivation of parameters, if this A, B, C are all constants, you have to find your own YC. Okay, through the characteristic equation. Okay, find YC. From the YC, you will get your Y1 and Y2. With the Y1 and Y2, you can compute for your Wronskian functions. Okay, and your AX is the coefficient function of Y double prime. Okay, coefficient function of Y double prime. This is your AX. This is your FX. Okay, this is the formula for the YP. So you just substitute all the Y1, Y2, and AW into the formula. Okay, then before you integrate, simplify first. Simplify, then only you start to integrate. Simplify. When you get a YP, combine to your YC. YC plus YP. Any questions?
Fine. Or minus x. It exists. I just simplify equals to 4 x equals to 4 of x. How do you make it? This is it exists. Shouldn't be y1
Yes, 1. Here or there?
Yes, the rest of it. 4 is this.
Which one?
Shouldn't be y1 here.
Y1.
It's because you simplify here.
Y1. Yeah, this is Y1. E negative x is Y1.
How to change?
Because you have 4 here. You can factorize the 4, you can factorize the negative. Okay. After you factorize, it will be simpler. After factorize -4, and then you combine 1, 2, 3, 3e into 1.
I get it.
Because without, if you didn't combine into 1e, how are you going to integrate this one? You have to simplify in the simplest form before you integrate. Any more questions? I remind you once again, final exam. Okay, final exam topic. Any more questions? Okay, now we look at 1b. Okay. A, B, C are constants. So solve the homogeneous differential equation first. Form the characteristic equation. Get YC. Whoever sign for your attendance? Attendance? What is your n? 2. 2. So that means n1 and 2 are the same, which is 2. So in case 2, your YC will be C1 E2x plus C2x E2x. Okay, insert an x to the second term. Okay, then we find for the Wronskian. Product rule. Okay, product rule. Minus BC. Okay, so expand E4x plus 2x E4x minus 2x E4x. Okay, so that means your Wronskian function is E4x. Okay, E4x. substitute your y1, y2 as a w.
When it's supposed to mix. Look, look, so what it means is the next so what is the
y1 is e to x. y2 x e to x. Your fx is x plus 1 e to x. Over a is 1. Okay, a is 1. W is e for x. Simplify. But if you look at my sigma slightly. You can't get to factorize anything. So this one, you simplify it. Polynomial, multiplying polynomial. And then exponential, what is the new power? One, two, three. What is the new power? 0. E0 is 1. Plus x e to x. Okay, here you have x plus 1. Combine 1, 2, 3. E 0. 0. 2 plus 2 minus 4. So E0 is 1. Okay, means that we are just integrate this. Okay. Okay, this is x squared plus x. This one, this is x squared plus x, right? X squared plus x. So when you integrate x squared, you get x cubed over 3. X, you get x squared over 2. Then simplify. This one combined with this 1/2 minus 1/3, you get a 1/6. Negative half combined with 1. 1 minus half, half. Okay, so this is your YP. Okay, then finally, combine YC to your YP. YC plus YB. Any questions? Yes. There. If no question, we continue to question number 2. Interrupt this. Okay, question number 2. You are given YC. You are given YC because the A, B, C are not all constants. A is x squared, B is 3x, C is -3. Okay, these are not constants, so that's why the YC is given. When you have the YC, that means you have the Y1 and Y2, where you can compute for the rod scale.
So you want, then, we have one eight because of the variables. And one and two X, so we can't get one. Well, because it's
a constant. This is not a constant. This 3x is also not a constant. You can find your YC on your own only if this, and this are all constants.
We have one seven.
Otherwise, you will be given a YC. So your Wronskian is -4x about -3. And your 8x is this one, x squared. Okay, your fx is 1 over x.
See.
Okay, then put all this into the formula.
X with X. X also central. Minus 3. Yes, X to 4 minus 3. When the top of the last group, I guess we know. That's minus 7 X, minus 7 X. Add X minus 8X. You jump. Let's have a good well, it's
Any questions?
Doctor, YC, he gives us the YC? YC.
YC?
Yes. It's given or not?
Oh, YC.
Yes.
YC is given from the question. Yes. These two are given in the question. Okay, now, what is the constant that you can factorize? Negative 1 over 4, right? Negative 4 here. Okay, that's mean 1 over -4. It means -1 over 4 times this. You get a positive 1 over 4 x. Okay, then x combined into 1. What is the new power?
Zero.
Zero.
Negative 3.
Negative 3. Negative 3. Okay, how to get there? Negative 3. Negative 3. This is -1, right? Plus -1. Minus 2 minus -3. Okay. So you have -3. And goes to the second term. Factorize the -1 over 4. combine all x into 1, then what is the new power? Power of 1 minus 1 plus 3, 1 plus, this is -1, minus 2 minus -3. This means 3 minus 2, 1. Okay, then you can proceed. Okay, proceed to the integration, then simplify to get your YP. According to the question, okay, question number 2, this one, okay, it just want you to find a particular solution. Find a particular solution of each of the problems. Meaning that once you get your YP, done. Okay, it wants you to get the particular solution of it. If the question sounds like it wants you to find for the general solution, meaning that once you get YP, combine to your YC to get your general solution. Okay, so x power plus 1. Power plus 1. Simplify. -1/8 x power of -1 minus 1/8 x power of -1. So this means you have -1/4 x power of -1. So this is your particular solution. Any questions? Now we look at QB. Find for the Wronskian function.
هي ضرب السلبان واحد اللي قلنا بعدين قسم من واحد سلبان ما يوصل بس يعني ضرب واحد
X is x squared. X is 72. X to the power 5. Factorize the constant. 72 over -2 is
6.
-36. Okay, -36. So negative, we get a positive 36. Next. Okay, 1, 2, 3, 4. Combine into 1x. What is the new power? Three. -1 plus 5 minus 2 minus -1 is 3. The same goes to the second term. We factorize the 72 over -2, which is -36. Next power of -1. Okay, 1, 2, 3, 4. New power is
5
5. Minus 2 minus -1 is 1.
اي معين طيب
على 60 أشهر إكس 4 صح؟
Okay, any questions?
أنا كيف طلع هذا
فهذا إكس 1 بعد 70 بعد ما يفرق
بس 30 36 صحيح؟
Okay, now pass your question papers. Okay, question 1B. Okay, 1B. Consider a non-homogeneous equation below. This one. Choose a suitable method to construct the general solution for the question above. So this one, it should be undetermined coefficients method or variation of parameters. Which one? Look at the fx. Look at the fx function. Can this stop using undetermined coefficients method? No. This is not acceptable for sec. So we have to use variation of parameters. Okay, you have to use variation of parameters. And you are given the hint here, cosecant is 1/sin. Okay, this one you can try on your own. And we look at another year, okay, 2 years back, this one. Okay, question 1C. Consider a non-homogeneous equation. Okay, this one, sine 3x. Compute the general solution for this equation by using a method with integration involved. Which one? Variation of parameters. Okay, so you have to use variation of parameters. If you use undetermined coefficients method, meaning that you don't get any point. You don't get any points. You have, when you use the wrong method mentioned, that means you didn't get any point. Even though you get the correct answer. Okay, another one. Okay, choose the suitable method to construct the general solution of the non-homogeneous equation below. 2 cotangent 5x. So obviously, variation of parameters, right? Because this is not acceptable, not applicable for undetermined coefficients method. Cotangent is 1/tangent. Okay, 1/tangent. So here you are given a hint. Okay, when you are integrating 1/sin kx, you will get this. Meaning that when it comes to the integration part, when you need to integrate 1/sin kx, you can apply this directly. Okay, if this is sine 3x, meaning that it will be 1/3 ln cosecant 3x minus cotangent 3x. You just use the hint given. Okay, just use this. for this when it comes to the integration part. Okay. I just show 3 years back, until 3 years back. Okay. So now we have done this one is on week 4. This is week 4. Can I move to week 5 lesson? Because later in Ryan next week, is it? Next week. Next week, Ryan. So if possible, okay, if we prepare the schedule, we may have that means we can have no class during that week. Okay, it depends. It depends. It depends on the pace because this is for week 5. This is for week 5. If you are able to get this done by this week, that means no class next week. Okay, this is for week 5. Okay. Okay, this chapter 3. Okay, chapter 3 is about Laplace transform. And this Laplace transform, for this part 1, it will be covered under your midterm. Okay, this part 1 covered under your midterm. Okay, now we look at the definition of Laplace transform. This is covered under midterm. No, the other one. The Okay, now we look at the definition of Laplace transform. Okay, this is the definition of Laplace transform. Okay, this one. Okay, ft is a function defined over starting from 0 up to infinity. Okay, so we are integrating from 0 up to infinity for this function. Okay, ft. Okay, ft. So this transform, okay, this transform, actually we are transforming the domain from domain T into S domain. Okay, the ft, this one, initially it is in T domain. So after the Laplace transform, it will be transformed into S domain. Okay, and the Laplace, okay, this word Laplace, the L, we will use this symbol, okay, the L in Greek letters, okay, form. So when we Laplace the ft, we will get the f in S. So after Laplace, everything will be in S, no more T. Okay, and there are 2 ways. Actually, there are 2 ways to do the Laplace transform. One is through the definition. Okay, this is the definition. Another one through the table. Actually, this table is also obtained from the definition. Okay, from the definition. And now we look at the, what is the definition of this Laplace transform first. Okay, so if we want to Laplace transform ft, we have to multiply the ft with exponential function. Okay, with exponential function to the power of negative st. Okay, we have to multiply the function with e negative st. Then we integrate from 0 up to infinity. Then we will get the fs. Can we look at one example? This one. Transform Laplace transform ft equals to t. Okay, Laplace transform this ft. So we will multiply this t to the e negative st. Okay, multiply the t to the e negative st. And then we integrate from 0 up to infinity with respect to t. So initially, you see, we are Laplace in the bracket t. We Laplace this one. Okay, that's why the t multiplied to this exponential function. Okay, so this is polynomial multiplied to exponential function. When it comes to the integration, we apply either integration by parts or tabular method. Okay, if we use tabular method, you will get this. Okay, you will get this line. If you use by integration, you get this line, then this line. Okay, so once you get this, we will substitute infinity into t. Okay, into t. But this one, okay, if you look at this, t is at the nominator. This one, e negative st under denominator. That means in the numerator we have t. In the denominator we have also t. And e to the power of infinity is infinity. So meaning that when you substitute infinity into the t and t here, you get infinity over infinity. Okay, you get a case infinity over infinity. That's why we have to use this L'Hopital's rule. Okay, when you have infinity over infinity, we use this rule. But there's no issue for the second term because your e negative st means that you have 1 over est. You have 1 over infinity. Okay, 1 over infinity. Okay, this one I write on the whiteboard. Okay, write on whiteboard. Laplace transform t by definition. If you see the word definition, means that you have to use integration. Okay, you have to use integration to get the transform, okay, to get the transform done. So this one, when let's say I use the tabular method, t and e negative st. So t differentiate until 0. This one integrate negative st over huh? Negative s, right? Negative s because we are integrating with respect to t. So once again, e negative st over s squared. Okay. Meaning that we will get negative e over s e negative st minus 1 over s squared e negative st, 0 to infinity. Okay. This one, yeah, I write in this form. Negative t over s e s t minus 1 over s squared e s t. Okay, I write in this form. So now you can see clearly when you substitute infinity into t, you get infinity here. Over e to the power of infinity, also infinity. So you get infinity over infinity. So we can't substitute directly because you will get infinity over infinity. So you have to use this t tends to infinity. Negative t over s e s t. Okay, this one. For the case of infinity. Okay, minus. Now substitute infinity into this t. You have e infinity, that's infinity. 1 over infinity is 0. 0, eh? Minus. Now we substitute 0 into t. So what do you have? 0 over. When you substitute 0 into t, what do you get? 0, because you get 0 over s, right? 0 over s. Negative 0 over s. Okay, then minus 0, substitute into here. So what do you have? 1 over s squared, right? E0 is 1. E0 is 1. So you have 1 over s squared. So now you get this. Okay, so for this part, because you get infinity over infinity, we have to apply the L'Hopital's rule. So when you apply the L'Hopital's rule, it means that we are differentiating the numerator and denominator separately. Okay, separately. So differentiate t, you get 1. Differentiate this one respect to t. You have s squared e s t. Okay, minus 0, minus 0, minus, you get plus 1 over s squared. Okay, now you substitute infinity into t. What do you get? What do you get? 1 over, this is E infinity. E infinity is infinity. Infinity times s squared, still infinity. 1 over infinity is 0. So we have 0 plus 1 over s squared, which is 1 over s squared. And to get this, okay, actually we have done one assumption. We have done one assumption where your s is actually positive. We have made this assumption s is greater than 0 here. Here. Okay. From here to here, we have assumed s is positive. Why I say so? If s is negative, what's happened? If your s is negative, meaning that your exponential function will be here, right? If s is negative, e negative value, okay, and then t. If s is negative, that means this exponential function will be here. Then you get infinity times infinity. As a result, you get infinity. So we want to avoid to get the infinity. That's why we have the assumption s is positive. When s is positive, okay, when you substitute infinity into t, that means your e is still stay under the denominator. Okay, denominator, we have t at the numerator and this one at the denominator to get the infinity over infinity. After applying the L'Hopital's rule, then we can get 0. If you get infinity, imagine if your s is negative, your exponential will be here. You have infinity times infinity. You get infinity here. Then your result will be infinity. No matter what are the rest of the function, right? You will get infinity. But that That is not what we want. We don't want infinity. That's why we have this assumption. Okay, any question for this one? Okay, if no, we try exercise, try exercise. Okay, the question is find the Laplace transform of the following functions by definition. By definition, meaning that you have to use the formula just now. Okay, to integrate. You need to integrate. Okay, by definition means, okay, now we want to do the Laplace. This one, Laplace, we use this symbol. Okay, this symbol for the Laplace. Okay, Laplace 1. Laplace 1 equals to, because by definition we have to use this 0 after infinity, and then your ft times e negative st dt. Okay, your ft multiplied to the exponential function. So this one, it means we are integrating this e negative st dt. Okay, now we can start to do the integration. So what do you get? Integrate respect to t. Respect to t. E negative st over negative x. Over negative x, because you are differentiating this with respect to t, so you have negative x. Just like you are integrating EAT, you get EAT over A. Same goes to this one. Okay, then this one, okay, I rewrite. This will be SEST. Right? This will be negative 1 over SEST. Okay, now we substitute the infinity into t. So what do you get? E negative is infinity. E infinity is infinity. Infinity times s still infinity. 1 over infinity is 0. Okay, then minus 0 substitute into t. Okay, you have a minus here. So negative 1 over x. Okay, because E0 is 1 over x. So this means you get 1 over x. So what is the assumption? What is the assumption? S is greater than 0 because of this one. Here. We assume S is positive. That's why your exponential can stay in the denominator. Okay. Next one, EAT. EAT. Your FT is EAT now, so meaning that we want to do the Laplace transform for EAT. So EAT times E negative ST. The FT must be multiplied to E negative ST, then you integrate from 0 up to infinity. Okay. So before integrate, we can combine the two E's into one. We combine into one. So the new power will be AT minus ST, right? And we can factorize the T. Okay, we can factorize the T. So negative T S minus A. Right? This one you can combine into EAT minus ST. That's when E factorize A minus X. Okay. But we factorize a minus. We factorize a minus. That's why you get an S minus A here. Okay. Why we need the negative? Why we need the negative here? Later I explain. So when you integrate, you get E negative T S minus A over okay, A minus X. Okay. Yeah, and pretty much this one. We have 1A minus S exponential function T S minus A. Okay, we write in this form. You know, substitute infinity into T. What do you get? Infinity here, E infinity times this, still E infinity. E infinity is infinity. Infinity times anything, also infinity. So 1 over infinity, 0. Okay, 0. Then minus, when you substitute 0 into T, you have E0, which is 1. So you have 1 over A minus X. So that's mean this is 1 over S minus A, right? So what is the assumption that we have made so far? S is greater than?
S minus A.
S is greater than? A. S is greater than A. Why? Here, this one, we assume this is positive. That's why your E can stay here. Okay, we assume this one as positive. So S minus A greater than 0, meaning that S is greater than A. Okay, because of this, is assumed as positive. That's why your exponential can stay here. Otherwise, okay, if this S minus A is negative, your E will be here. When your E is here, that means E infinity is infinity. You will get infinity here. Okay, so now you see why we need the negative here. Okay, if we use this, you can't let your E stay underneath. We want the negative because we want E stay underneath. Without the negative, okay, without the negative, if you leave this in this form, your T, E will be T right here. Your E will be here. Okay, any questions? So far, across the years, so far there is only 1 year. By definition, is asked in final exam. The rest of the years, we use the alternative way. The alternative way is simpler, much simpler than this one. Okay. But still, you need to know this, how you get the Laplace transform through the definition. Plus 18. Okay, so we need to multiply the cos 80 to the E negative ST. Cos 80 multiplied to the E negative ST. You have the T under the cos function, you have the T under the exponential function. So how do you integrate this? Cos and exponential function, how do you integrate this? Tabular method. Okay, you can use tabular method, okay, or integration backwards. So tabular method, can I wrap this off? Tabular method. Let's say which one to be here. Okay, I choose this to be here. This one to be here. It can be the other way around. It can be cos here, exponential here, doesn't matter. Okay, so this one, when you differentiate with respect to t, minus c x minus x e negative x t. Integrate. Okay. Then one more. Okay, one more time. S square e negative st. This one more time. Negative cos at over a squared. E negative st dt. Okay, I solved the one without limit first. Okay, I solved the one without limit. Okay. So from here we have 1 over a e negative st sine a t minus minus minus, but minus s over a squared E negative st cos at. That's correct. 1 over a e negative st sin at minus s over a squared e s e negative st cos at. Then, okay, one more. Because this is not 0, we can't get 0 from here. So the last one, it must be horizontal arrow. The one horizontal arrow, it must come together with the integration sign. Okay, so plus, minus, we have minus s squared over a squared e negative st cos at. Okay. So this one, this is a constant, right? This is a constant where we can factorize. We can factorize. I just write it. I just write it this way. Huh? We factorize the x squared over a squared. Okay, this is your left hand side. This is your right hand side. And you have the same term of this. They're the same, right? So we move this last term to the left. Move this last term to the left. It means that this is 1. 1 plus s squared over a squared. 1 plus s squared over a squared, and then the integration, okay, e negative st cos at dt equals to the two terms. I repeat, 1 term on the left, 3 terms on the right, and this the third one, this term is same exactly as this. So we move this term from right to the left, and this is 1. So we have 1 plus s squared over a squared. Okay, we factorize this term. Okay, then equals to the right hand side 2 terms. So what is this? When you combine this, we combine this one, you have a squared plus s squared over a squared, right? Okay, this one combined into 1. Right. One more time. E negative ft cos at dt is 1 over a e negative st sin at minus, same thing as the
How can we get the term? S squared plus s squared over a.
this one to this. Combine, this is a squared over a squared. A squared over a squared plus s squared over a squared. Okay. Now we want this. We want this. So this one move to the right. We move this to the right. We want this term on the left. So it means a over a squared over s squared plus a squared.
And then let's
So that's you can cancel out the a and a square here. So now we want to substitute 0 and infinity. Okay, infinity and 0 into the t. Okay, and write one more line here. You see now, this is what we want. This is what we want. Okay, but we have already got the one without the limit. So meaning that if you have a 0 up to infinity here, meaning that here also 0 up to infinity. Okay, because this is what we want with 0 up to infinity. So meaning that right hand side 0 up to infinity. So now we can start to substitute. We substitute the infinity into this function. Okay, now infinity into here and here. What do you get? Infinity into here and here. I think I write one more line so that you can see. This is sine a t over a st. This is s cos a t over a square e st. Now substitute infinity into here and here. We look at this part first. Sine infinity. If this is infinity, we have sine infinity. What is sine infinity? When you sketch the curve of sine function, what is the max and min? 1 and -1, right? It depends the values here, right? If this is 1, your sine function is from -1 up to 1. So it won't go to infinity. It's just a constant within -1 and 1 when you substitute infinity into here. Okay, just a value. But here, when this is infinity, E infinity is infinity. A normal constant over infinity, you get 0. Okay. A value between -1 and 1 divided by infinity, you get 0. Okay, I combine here. Continue here. Okay. So here, when infinity goes into here and here, you get 0. How about here? What about here? When infinity goes to this and this, same thing, 0, right? Because cos function also depends on the value. This s is just a constant. So you will get a constant over infinity, which is 0. Now, 0 into t. 0 into t. Sine 0 is 0. E0 is 1. So 0 over a. 0 over a is 0. Okay, last one. Cos 0 is 1. So 1 times s, you have s. 1 times s, you have s. Over E0 is 1. E0 is 1. So it's a squared. Right? Okay, meaning that what do you have here? Minus, minus, you get a plus s over a squared. So you can cancel out the a squared. So you have s over s squared plus a squared. Okay, and what is the assumption made? Assumption. S is greater than 0. Okay. Any questions? Any questions? Do you want me to repeat for this one? Ft cos t. We want to Laplace transform the cos at by definition. By definition means when we Laplace this function, by definition, we have to multiply this function to the e negative st, and then integrate from 0 up to infinity. Okay, this function we are integrating using tabular method. Okay, using tabular method. So from the tabular method, this is what we obtain. Okay, this is what we obtain through the tabular method. So I first solve the one without the limit first. Okay, I solve the one without limit first. Otherwise, you need to keep repeating 0 infinity here and there. So I leave out the 0 to infinity first. We solve for this function. Okay, so after you solve using tabular method, you get these 3 terms, and you found that this term is actually same exactly as this. So we move this last term to the left. So this is 1 times this. This is s squared over s squared times this. Okay, there's a minus here. So when we move this to the left, you have 1 plus s squared over a squared here. Okay, this is from here. Then on the right, you have these 2 terms. These 2. Then this one we combine into one function. This is a squared over a squared. So that's why you have a squared plus s squared over a squared. Okay, you have this. Okay, this one, the rest, same as this line. Okay, we just combine this into here. And next, what we want is this one, this part. So we move this to the right. Okay, we move this to the right. That means you have a squared over this function. Here, a squared over this function on the right. Okay, for this whole function inside the bracket. Okay, what we want is 0 up to infinity. So if this is 0 up to infinity, means that here also 0 up to infinity. Then we substitute the infinity into t. Okay, but before you substitute, I rewrite this into this form. Okay, it will be clearer for you to see. Okay, e here, e negative is here. Okay, so infinity goes into t. We know that sine at is a curve oscillating from -1 up to 1, because here is 1. So the value maximum, it will be 1. Here, when t is infinity, e infinity is infinity. So 1 over infinity, you get 0. And for this term, okay, cos function also, it oscillates from negative s to positive s. Okay. So the maximum, the largest one is s. So s over infinity, also infinity. Okay, then minus the substitution of 0 into t. So sine 0 is 0. 0 over E0 is 1. So that's mean over A. Okay. 0 over A is 0. This 1, 0 into cos function. Cos 0 is 1. That means 1 times S, you have S over A squared. Okay, S over A squared because E0 is 1. Okay, so S over A squared. So this whole thing is S over A squared. Okay, minus, minus, we get plus. Lastly, we cancel out the A squared, so we have S over this function. With the assumption of S greater than 0 because of this. S is positive, that's why your exponential function stays in denominator. Okay? Okay, before we end the class, I want to show you why we need all this. Okay, give me 2 minutes, 2 minutes. Okay, this one is important because this is coming out in your midterm, final exam, quiz 2, assignment, I think no. Okay, so this one is important where we will, you will start to learn this one in next class. Okay, so you see just now with Laplace 1, we get 1 over S with the assumption of S greater than 0, right? This is what we did just now. And just now the question B, EAT, you get 1 over S minus A. And the assumption is S greater than A, right? And for the cos function, this is the last one. We get this, and S greater than 0 is the assumption. So this is actually the formula of Laplace transform. Okay, this formula will be given in any of the assessment as long as the assessment involves the question of Laplace transform. Then you will be given the table. Okay, actually, to Laplace transform, it is very simple. We just need to identify what is the value of A. Cos 2t. Cos 2t after Laplace transform, it will be f over s squared plus 2 squared, which is 4. Okay, that means the Laplace transform actually is very simple because you are using the table, but where we get this table is all by definition. From the definition, we get all this. Okay, so what you learned just now is the basic definition. Then when you have this table, then you can solve the Laplace transform of this kind of functions. But of course, these are the basic. Okay, these are the basic. You have to know this basic before you move on. Okay, this one we will look at this on this Friday. Okay, Friday, how many of you will come to the class on this Friday? Hands up, I want to see, I want to estimate. So almost all okay. So for those who want to attend face-to-face class, you can attend the online class. Okay, but for the quiz one, I think most of the students choose for Thursday, right? Thursday night. It's more than 50%. Okay, 50%. So I guess we have 107 students. So that's mean I think we will go to we will go follow the majority. Okay, Thursday night. Okay, so I will see you this Thursday. This Friday.
Oh, Thursday we have an assignment. Thursday we have an assignment. So what about?
Which one it covers the topics under week one? The order of the differential equation, linearity, homogeneity, ODE, PDE, independent, dependent variables, all these basic one. Separable equation, is it separable? Is it linear? All these kind of questions. So you have, I think 4 short answer question, 3 multiple choice question, and 2. Is it 2? And true and false question. I forgot how many questions, but altogether 10. Okay, altogether 10. So even though that time you are traveling in bus, you are still can answer to the question. Okay. Any more questions before we end the class?
Question half an hour. 10 question half an hour. 10 minutes.
10 questions in 30 minutes. Very short one. What is the order? Then you just look at the derivative, you know what is the order. Okay, so I'll see you this Friday.